Hello everyone, today we're talking about polynomial functions and their graph, section 3.1 in our book. So here they want us to sketch the graph of the function by using the transformations that we learned in chapter 2. The only difference here is going to be that it's going to be in a general form, y equals x to the n, where n is going to be, greater than 2. So chapter 2, we worked with most things that had a degree of 2. Now we're going to deal with things that have degree 3, degree 4, degree 5. So higher degree. And then they want us to indicate all the x and y intercepts on the graph. So they've given us this function of degree 3. So the highest degree involved in that polynomial function is how we'll define it. So it's a degree 3. And they want us just to sketch it knowing that, or expecting us to know that y equals x to the 3, so the base function. They expect us to know what that looks like, and then just use some transformations from there to graph it. So I'm going to show you real quick on the calculator because we probably are not 100% sure what that looks like yet. But as we go through the chapter, we'll be able to know what the base functions look like. So real quick, we can see that our x cubed, so our y equals x cubed, looks something like this. So if I go over to my chart here, I can just draw basic sketch is going to look something like that. So now I'm going to use what I know about transformations to sketch this graph. So the negative out in front of my whole equation means I'm flipping it over the x-axis. The negative 3 inside means I'm moving it to the right 3, and the positive 2 outside means I'm moving it up 2. So that means I should be at the point, so here we can see it crosses at the origin. So now it's kind of like going to cross at the point 3, 2. And since we flipped it over the x-axis, it's going to look something like that. Right, and they just want a general rough sketch. So there we've seen a rough sketch. Now we're actually going to have to use our calculator to find the x and y intercepts because they're obviously, here it was 0, 0, so we can't use anything from the base to gather our x and y intercepts. So let's go to our calculator and calculate this x-intercept and then the y-intercept a little further on up there. So on our calculator, I have already graphed our equation after the transformations. Looks something like that. So now to find this x-intercept here, that is called a root. And in this case, also a 0. So we're looking for the 0 or the root of the function, and that's where it crosses the x-axis. So it says it wants us to find the 0, so let's get close on the left side, get close on the right side, and then guess pretty much right there. Close enough. And we can see that our 0, our x-intercept is 4.26. Remember, we're going to round to the hundredths. To find our y-intercept, all we have to do is go to the chart and see when x equals 0, y equals 29, because when x equals 0, y equals 29, that's when we're hitting the y-axis, right? So using our calculator, we can see the x-intercept was 4.260, and the y-intercept was 0.29. Okay, so what we should gather from this is just we can use the same sort of transformations that we learned in chapter 2 to manipulate our graphs again in chapter 3. Okay, so next they want us to again sketch the graph of the function and label all intercepts. And now they're also throwing end behavior in there. So when we get to the graph, I'll show you what they mean by end behavior. So in order to graph this, they've just given us the zeros of the graph. So they've just given us the factors, zeros, okay, the roots, they all mean the same thing. So these are where our graph will cross the x-axis. So we can kind of get a general idea of what's going on. But to get a better idea of what's going on, let's solve. So let's distribute it back out. Let's FOIL it back out and then graph it. So as we FOIL, we get x squared minus x minus 6 times x plus 1. And then that gives us x cubed minus 7x minus 6 after we simplify. So again, I'll go ahead, plug this in, and see the type of graph that we get. Okay, so we get a graph that looks like that, right, where it crosses the x-axis at -2, it crosses the x-axis at -1, and then it crosses the x-axis at 3, because -2 makes this 0, 3 makes this 0, -1 makes that 0. That's why they call them the zeros or the roots. So, a basic sketch of this graph. We've got our roots at -2, at 1, and then at +3, and our graph looks something like this, with the y-intercept I have already found to be -6. So I found the y-intercept to make it a little more neat. And in the question, it actually asks us to find the x and y intercepts. So I found it beforehand just to help me sketch my graph. So x-intercept, we have the points -2, 0, -1, 0, and 3, 0, with a y-intercept of 0, -6. So now we've sketched our graph. Okay, we have found our intercepts, and next we need to talk about the end behavior. So what the end behavior means, as I go to the left, as I go to -infinity, what is my graph doing? Well, as I go to the left here, right, as I go to the left, my graph is going to -infinity. So I just say as it goes to the left, it goes to -infinity, and we can write it just like that. As it goes to the right, it goes to +infinity. So that's what they mean by end behavior. Just what's happening at the ends of our graph, because we're going to be dealing with graphs that go on forever. So an important thing to know. And one thing I wanted to mention before I go on to this, since this is an odd degree, right? 3 is odd. So if we had a 2 or 4, that'd be an even degree polynomial. So this is an odd degree polynomial. Since this is an odd degree, as long as a is positive, this is always how our end behavior is going to look. Right? It's going to fall to the left, rise to the right, if you want to think of it like that. If it's a positive even degree, right? So if it's positive even degree polynomial, it's going to rise to the left or go to +infinity, and it'll also rise to the right, go to +infinity. So if it's positive and even, left and right, both go to +infinity. And then obviously this will be reversed. If it's negative and even, they both go to -infinity. And if it's negative and odd, right, we're going to have the left go to +infinity and the right go to -infinity. And you'll see more examples as we go through it in class. So again, they want us to sketch the graph of the function, label the intercepts, and observe proper end behavior. So this function, I just went ahead and graphed it in my TI-83, so let's show that real quick. Okay, so we get a graph that looks like this, and I forgot the negative. Right? So when we plug that negative in there, this gives us a graph that looks like this. So here we have even degree, right? And we negated it, so that's why it's going, my left is going to negative infinity, my right is going to negative infinity, right? So falling to the left, falling to the right, and then let's just plot a couple points. So if you look at your table, you'll actually see the y-intercept is at 4. The x-intercepts are at 1 and negative 1. And we saw my end behavior going to negative infinity on the left, going to negative infinity on the right, because it is an even degree and we've negated it. So instead of typically an even degree, if it's positive, it's going to go up. But since it's a positive, since it's an even degree and it's negated, it's going down. Finally, they want us to graph this polynomial with this window. So when they give us this like this, they want us to use the window where x is minimum of -5, maximum of 5, and my y is minimum of -100, maximum of 100. So they're asking us just to graph this on a calculator and then find the coordinates of the local extrema, those just being minimum and maximum. That's all the extrema really means, and then correct the 2 decimal places. So let's graph that real quick. And I forgot to change the window, that's why it looks so weird. And I want both of these to be 100. Alright, so that gives us a graph that looks like this in the appropriate viewing rectangle. Then they want us to find the local extrema, that just being the 2 minimums and the maximum here. So I'm going to go ahead and find the local minimum over here. Go to the left, go to the right, and then guess about where it's at. And when we do that, we can see that the minimum is at -3 and -3.000001. It's basically saying it's at 3. Your calculator just can't evaluate it perfectly, but we're going to say that the minimum is at -3, -49. So local extrema, one, we have a min at -3, -49. We also have another min over here at +3, -49. I've already gone ahead and checked and made sure. And then we have a maximum. We have a maximum right here, and that maximum is at the point 0.32. So I know we know how to find mins and max. I'm not going to redo the process for these two. You guys should know how to do those. But one thing I did want to mention is here, this is an even degree, right? X to the 4th even. So my end behavior, we can see as we go to the left, my graph goes to positive infinity. So that holds when I have an even degree and my A is positive. As I go to the left, I go to positive infinity. As I go to the right, I go to positive infinity. So just to reinforce end behavior. So go ahead, do the example problems that accompany this in the PowerPoint, and we'll talk about this in class tomorrow.